All right, let's get right into it. When you think about AI, one of the first things that probably comes to mind is just how much energy it uses, right? But what if I told you that's, well, only half the picture? Today, we're going to look at an analysis that totally flips that common idea on its head. We're not just looking at AI's energy use in a vacuum. Nope. We're comparing it to the human alternative. You know, the very people these systems are often built to help. So let's see how this all really shakes out.
Yeah, the headlines are everywhere, aren't they? AI is an energy hog. The carbon footprint is massive. And look, there's definitely some truth to that. We're not going to ignore it. But the whole point of this analysis is to ask a really simple but kind of profound question. Compared to what? That's the key right there.
Okay, so let's tackle the elephant in the room first, the big, scary number you always hear about. Just to train a model like GPT-4, we're talking about a staggering 50 gigawatt hours. I mean, that's just a massive amount of power. And, it makes sense why that number gets so much attention. It's huge.
So what does 50 gigawatt hours even mean? Well, try this on for size. It's enough juice to power thousands of homes for a whole year. So yeah, that upfront cost to build the thing, it's gigantic, no question about it. And the concerns about that are totally valid. But here's the thing to remember. That's a one-time cost, a sunk cost really.
And this is where the story takes a really interesting turn. Okay, so the training is done. It's built. Now what? What does it actually cost, energy-wise, for the AI to do a single thing for you? To answer one question, to perform one task. That's the real question, isn't it? So let's dive into that.
All right, first up, let's look at the AI side of this. We're going to zoom way in from that huge training number to the microscopic amount of energy it takes to do just one thing, like, say, write a quick bit of code. And boom, here it is. For one single query to a model like GPT-4o, we're talking about just 0.0003 kilowatt hours. I mean, that is an absurdly tiny number. It's almost nothing. But what's even crazier is what's packed into that tiny little figure.
See, this isn't just the power going to the computer chip itself. Nope, this number includes the whole shebang, the server running the calculation, the AC and lights keeping the data center cool, and get this, it even includes a teeny tiny fraction of that huge training cost we just talked about, spread out over all the billions of queries it'll ever do, so it's a really complete number.
Okay, so we've got our AI number. It's tiny. Now let's flip the coin and look at the other side of this comparison, us. And trying to figure out the energy cost for a human to do some brainy work, well, as you can probably guess, it's a whole lot messier. Because if we really want to be fair here, an apples-to-apples comparison, we can't just count the calories a person burns while thinking. That's not the full story. We've got to look at the entire system, everything that goes into supporting a knowledge worker, like a programmer or a writer, for just 1 hour of their work.
So the analysis breaks it down into three main buckets. First, there's the energy your body itself burns, just to keep the lights on and your brain firing. Second, there's your piece of the pie for the office energy, the lights, the AC, your laptop, all that stuff. And then there's the third one, and this is the real kicker, the one most people never think about, the hidden energy cost of the food you eat.
This is where it gets wild. Think about everything it takes to get food on your plate. The farming, the processing, the packaging, the shipping, all of it. Well, it turns out that all that energy is somewhere between 5 and 10 times the actual calories you get from eating the food. And this one hidden cost is by far the biggest part of a knowledge worker's energy use per hour. So, you add it all together, right? Your body's baseline energy, your share of the office power, and then this massive hidden food energy cost. You crunch all those numbers for just 1 hour of work, and the total for a human programmer comes out to something like 1.5 to 2.0 kilowatt hours. Remember that number.
All right, the moment of truth. We have our two numbers. We've got the tiny, tiny cost for the AI, and we've got the surprisingly big number for an hour of human work. Let's see them next to each other.
And there you have it. Look at that. On one side, you've got the AI at 0.0003 kilowatt hours. On the other side, the human at 1.5 to 2 full kilowatt hours. I mean, the difference isn't just big. It's not even in the same ballpark. It's a completely different universe. When you see it as a chart, it's just stunning. If that big bar is the energy for a human programmer for an hour, the AI's bar is, well, you can barely even see it. It's just a sliver. So the real question is, just how much more efficient are we talking about here? Let's put an actual number on that gap. For a similar kind of thinking task, this analysis finds that the AI is Around 5,000 times more energy efficient. Yeah, you heard that right. 5,000 times. That's not a typo. When you look at the whole picture, the AI uses literally thousands of times less energy to do the same kind of programming task that would take a human an hour.
Okay, so right now you're probably thinking, fine, that's for coding, but what about everything else? Totally fair question. And the analysis actually looked into it, and what they found is that this pattern shows up pretty much everywhere in knowledge work.
Take a look. It's the same basic story across the board. For writing, we're talking hundreds of times more efficient. For something like design or illustration, it could be up to 1,000 times. And then you look at fields like medicine or law. For those really repetitive tasks like checking scans or reviewing documents, the energy savings are just astronomical.
But hold on. It's really important to say that this isn't the entire story. Numbers like these don't exist in a vacuum, right? There's some really important context and some limitations to this way of thinking that we absolutely have to talk about to get the full picture.
So here are a few things to keep in mind. First, we humans are always on. We're burning energy 24/7, whether we're working or watching TV. The AI only uses power when you ask it to do something. Also, what if the AI gets it wrong? If you have to ask it 3 or 4 times to get the right answer, well, its efficiency starts to drop. And probably the most important point, this is only about energy. It says absolutely nothing about the massive social and ethical questions around jobs and what this all means for society. That's a whole other conversation.
The person behind this analysis, Peter Graf, really sums it up perfectly. He says that when you look at it holistically, these models aren't just energy hogs. They're actually really efficient alternatives to human programmers. It's all about changing your frame of reference from AI versus zero to AI versus the human doing the same job.
So, what's the big takeaway here? The point isn't that AI is free when it comes to energy. Of course it's not. The key idea is that for certain kinds of tasks, especially that repetitive brain work, AI could be a dramatically more sustainable path forward compared to how we do things now. It just opens up a whole new way of thinking about what sustainable technology could look like.
And that really leaves us with a huge question to chew on, doesn't it? It's pretty clear that just looking at a single energy number doesn't give us the full story. Not even close. So as AI gets more and more powerful, how are we going to measure the true cost of progress? One that balances energy with human impact with social change? Figuring that out might be one of the biggest challenges we've got ahead of us.